Hi guys, welcome back to Math 115. Today we are starting the actual topics. So we're on section 1.1, the very beginning. This is on an overview of statistics. So before we do anything else though, I just want to give you guys a quick overview of how you go about doing your classwork. We talked a little bit about this in the introduction video, but here we actually have the notes in front of us, so let's work on it. First thing that happens when you click on that link, you get this screen right here where it gives you the option to open your notes with the Google Docs. So I'm going to click on that with the Google Docs. That sounded very darky. Okay, so anyways, once it's open, you only have viewing permission, so you're not able to make any edits. And so what you do instead is click on File at the top left and make a copy. And you can rename it if you want to, or you can just leave it as copy of chapter 1.1 notes. And then now this becomes your own copy to work in. And you can actually go in and type your answers here. Answers here. And then once you're finished with all, you're gonna watch the end to the end of this video. I'm gonna give you all the answers, and then you have everything filled in. Once you do that, then you just click on the top right, share, copy link, and make sure it's set to anyone with the link. Copy link, and then that's what you can input into your classwork assignment. You just paste it right into that classwork. Okay, so anyways, here we go. This is 1.1. An overview of statistics, and this section really it's exactly what it sounds like. It's an overview. It's pretty straightforward, I think, but there are a couple important things that we need to know that are really gonna play a big part for the whole course. And those two things are really separating what's the difference between the population and a sample, and then along with those things, what is the study of numerical characteristics of that population, and what's the difference with that compared to numerical descriptions or numerical characteristics of a sample. Okay, so let's go into the vocabulary to start. And we typically will start this way for our notes. We're just going to give a quick overview of what the section's about, and then we'll get down to the actual questions. So here I've got the words on the left, and here's the actual definitions. I also recommend that you don't just take my word for it. You don't just rely purely on these videos and notes, but that you are looking at the lesson media that's assigned in MyLab Math. Actually, that's my expectation, right? That you don't just rely on this one short video, but you also are reading the chapter or looking at the PowerPoint. Okay, first word is data. Data consists of information coming from observations, counts, measurements, or responses. So kind of like what you probably intuitively expect data is. Observations, counts, measurements, or responses, and the information from those things. Now, statistics. Statistics, actually, we use the word statistics in two different ways. The first way with this capital S, it's the course that you're taking right now, right? You're taking a statistics course. What does that mean? It's the course of the science of collecting, organizing, analyzing, and interpreting data in order to make decisions. So that's what statistics is from a big, broad perspective. For a little further down, we see a different definition for statistic. This big statistics is the field of statistics, whereas this little one is what does the word statistic mean? Okay, let's look at the next term. Population. A population is the collection of all outcomes, responses, measurements, or counts that are of interest. So big keyword here is that word all. And another thing to note here is if you look at the definition for population, it's the collection of all outcomes, responses, measurements, or counts. But doesn't that look familiar? Look back at the definition of data here. Observations, counts, measurements, responses, outcomes, responses, measurements, counts. Basically the same thing, right? So what is it? How can you restate that? You can say a population is a collection of all data, really. That's what it is. Right? It's all the data. Whereas a sample is related to population in that a sample is a subset or a part of a population. So it's not all of the data, it's a subset of the data. So it's only some of it. So you can write it like this, some of the data. Okay, sorry guys, I'm not sure if you noticed this, but there's a slight glitch because there is some rustling in the background distracting me. Sorry about that. So it doesn't really affect you because the video is paused. Okay, so let's continue on. I was just talking about population and sample, right? And a sample is a subset or part of a population. Let me give you a quick example. So let's say your population is some data about the entire United States. So let's say you're collecting what's something interesting? Like let's say you want to know the average salary across the entire United States. Okay, so the data would be salary for I'm sorry, the population would be if you had salary data for every single individual in the entire United States. A sample would be some collection within that. So, there's good samples and there's bad samples. An example of a bad sample would be the data only from Hawaii. So if you had all the individuals from Hawaii, then that would be technically a sample of the population, but it's not a very good sample, right? Because why? Of course, Hawaii is one very particular part of the United States. It's not going to be a good representative of the entire United States, right? So to be a good sample, what you actually want is you want something called randomness. You want to just pick and choose at a completely random fashion from all of the entire United States. Later on, we'll talk more about that. I think that's in section 1.2 actually, where that's a big topic of section 1.2. But for now, just know that a sample is any subset contained within the larger population. One more thing I'll say about population and sample, colloquially, that is to say, the way that we kind of think of population and sample, a lot of times we sort of loosely say population is like the individuals as opposed to the actual data. So what I mean by that is, let's come back to that example of the salaries across the United States. You might think of like the people, the citizens of the United States as a population, and then the sample would be any collection of citizens within that population, maybe like 100 or 1,000 or 1,000,000 citizens. But technically speaking, by the definition, the population is actually the data about those citizens. Now, in practice, we kind of use both sometimes. So just kind of, I don't know, just kind of be wary of that. Some books and some people will say population talking about the individuals, but in actuality, technically speaking, it's supposed to be about whatever the data is that you're interested in. Okay, moving on. A parameter is a numerical description of a population characteristic. Okay, so this parameter goes with population, and a statistic is a numerical description of a sample characteristic. So parameter goes with population, and a statistic goes with sample. That's the difference. Otherwise, they're pretty much the same thing. Parameter, it's a numerical description of a population characteristic. So what's an example of a parameter? So let's say, let's come back to the example of salaries, right? So we have something like the average salary across all members of the United States. That would be a parameter if I'm talking about the population of the entire United States. Or if I want to look at something called the standard deviation, which we'll learn later, or the median. Let's say the median salary across the entire United States. Those will all be parameters because you're talking about all the United States, where the United States is my population, right? Contrasted with statistic, if I take the salaries of 100 individuals within the United States, then that's now a statistic. If I take the average salary or the median salary or the standard deviation of salaries across only those 100 or 1,000 people, that is now a statistic because it's only about the sample and not the entire population. All right, descriptive statistics, that's the branch of statistics that involves organization, summarization, and display of data. So statistics is largely broken into two categories. Descriptive is one. And, the English kind of tells you what it's about, right? The word descriptive, you're describing the statistics. Compared with inferential statistics, and again, the English kind of hints at what it is. When you make an inference, what are you doing? Let's take a pause and look up the definition of inference. So we get a nice precise word here. It's a conclusion reached on the basis of evidence and reasoning. The process of inferring something. What's infer? Infer is to deduce or conclude from evidence and reasoning, rather than from explicit statements. Okay, so what are you doing in inferential statistics? You're deducing something. And what are you deducing? Typically, what it is you're drawing conclusions about the population when you only have a view of the sample. So you're drawing conclusions about the population, oftentimes using a tool called probability. It's a big math tool that we like. And so you're starting with only a small view. Let's come back to that same salary view, right? The same salary example. Let's say you have a collection of 1,000 individuals across the United States. You average out the salary, and that gives you a picture of what maybe the average salary looks like across the entire United States. So you took that small sample that you're able to access, and from that you inferred something about the big population. And that's when you do something like that, that's called inferential statistics. Compared to descriptive, is just when you're telling what you see. You're just describing, you're displaying it, maybe putting it in nice charts or graphs so that you can kind of see what the trends are or see how things are broken down or see the percentage, distribution, things like that. Okay, guys, so that's this first introduction to 1.1. I know there's a lot of me talking, but I'm just gonna cut the video off here. If I talk too fast, then just just slow it down, rewatch it, pause it if you need to. After this video, the next video, we're gonna get into the actual questions. So I'll see you in one moment.